Let's look at how oceans heat and cool the atmosphere. We've been studying how Earth interferes with the sun to space heat loss path. So let's now dive deeper into ocean to atmosphere. How is heat, once stored in the ocean, lost to the atmosphere? Or stated as a corollary, how does the ocean heat the atmosphere? While the sun can store 1,100 times more energy directly into the oceans than into the atmosphere, it is only the surface of the ocean that heats the atmosphere. This is from Woods Hole Oceanographic Institute. It shows heat flux from the sea surface to the atmosphere over the past 60 years. If an associate of yours thinks that the atmosphere heats the ocean, please show them this. To get heat or cold to the surface, different types of stirring occurs to move heat left and right, up and down in complex ways. Stirring is caused by many different types of time-dependent cycles. Stirring is also caused by cycles that are not time-dependent. They occur when a critical energy threshold is reached. They include things as familiar as El Nino and clouds. All of those cycles mix together, sometimes adding to each other, sometimes canceling each other, to stir the pot, the great ocean pot. Different types of stirring can also cause different effects, global warming or global cooling. Earlier calculations showed how solar irradiation can increase ocean temperature, but oceans contain so much heat that they can also cause some global warming on its own. Here are two of many such ways. Without a change in solar output, the oceans can cause global warming when warmer water moves to the surface, displacing denser, colder water that drops. Without a change in solar output, the oceans can also cause global warming when mixing is low and clouds are absent. The sun bakes the ocean surface. Sailors fear this. Global cooling occurs when there is deeper mixing, thanks to the interesting thermal profile of the ocean. This is a common thermal profile for ocean temperatures at mid-latitudes by depth. Deep down, ocean temperatures are near freezing, but the surface that drives our climate averages a warm 19 degrees C. Global air temperature, the magenta up arrow, is always less than sea surface temperatures. Why? The atmosphere is the insulation blanket between the ocean and the cold of outer space. Currently, our global climate is about 7 degrees C cooler than global sea surface temperature. Cooling by deep stirring is something familiar, so we know the following example is true. A lot of stirring, stirring the pot, the great ocean pot. Apollo wants to cool the surface of an ocean of salted goat's milk. Hey, it was the only photo I found. Oops, sorry. Apollo, not George. The hot sun begins to shine onto the surface. At first, Apollo watches and doesn't stir. The surface of the milk warms. A bit of steam forms. The kitchen warms. Energy has reached a critical point. Apollo stirs the hot surface into the deeper cool milk. The steam goes away. The kitchen cools. The surface of the milk drops enough to reach a lower energy threshold, causing Apollo to stop stirring. Apollo awaits again for the next energy threshold. Just like we learned in paleoclimate science, climate change is just an old friend coming for a visit, a really old friend. Higher heat means higher energy, more storms, more mixing, until the energy triggers deep mixing and climate cools. While greenhouse gases are important insulators of our climate and key for climate equilibrium, they are not heat sources. If you want to discover what boiled your coffee this morning, look for the heat source. The two primary heating elements of our climate are direct sunlight, which is fast and fickle, indirect sunlight via the oceans, which is slow, lasting, and supreme. Per this NOAA diagram, the oceans heat the atmosphere via latent heat, sensible heat, and thermal radiation. That's the physics. Now for the empirical evidence. We know that the sun raised the temperature of the oceans not only because of the change in solar output over the past 127 years, but because something had to, and it wasn't the atmosphere. The buoys that NOAA and partners spread across the oceans have proven that sea surfaces are warmer than the air by a lot, most all of each day and night, nearly everywhere. The bottom line is that a cooler object cannot transfer heat to something warmer. It is the oceans heating the atmosphere, not the other way around. So now the only remaining question is, has the atmosphere risen in lock and step with sea surface temperatures? Let's look at NOAA sea surface temperatures below to see if they rose the same as climate change, 1 degree C. As you can see, sea surface temperatures rose 1 degree C. But do the wiggles of climate change follow the wiggles of sea surface temperature? Let's find out by looking at NASA Global Atmospheric Temperature above. The trends match, the wiggles align, ocean wiggles are less, and the correlation exceeds 90%. A 90% correlation between ocean and atmosphere means that the ocean explains about 80% of our climate. So what explains the other 20%? Sea surface temperatures inherently reflect year-plus long cycles that limited the allowable lag in previous precedence tests. With sea surface temperatures removed, however, decadal response was possible. Maybe this is where CO2 will shine. Nope, same minor league anti-forcing detected. So who are the other major league players besides our star pitcher, Sonny C? Are you satisfied with not knowing the unsolved 20% of climate change? If you want to know what boiled your coffee this morning, first study the heating elements, then study the insulation. The heat sources should explain most all of climate change. When the explained is upwards of 92%, then add in the insulation, the greenhouse gases. The forcing from atmospheric moisture and methane with the anti-forcing from carbon dioxide should explain the remaining 6 to 8%. Here are some random thoughts on where to look next.